Alright, today we're going to talk about analyzing functions. So this is where everything comes together. Talking about end behavior, domain and range, turning points, increasing, decreasing, and the zeros. This section here, or this page here, we are going to identify some characteristics of a polynomial function. So if you graph this polynomial function using Desmos, you should get something that looks kind of like this. So this is what your graph should look like. This is a cubic function, so the parent function is x cubed. And this function has three terms, so we will call it a trinomial. The end behavior, it's an odd degree with a positive leading coefficient. So as x goes to positive infinity, f of x is going to positive infinity. As x goes to negative infinity, f of x is going to negative infinity. The zeros, if you use Desmos, you will find that the zeros are at -4, -2, and 0. The domain, for all polynomial functions, your domain is from negative infinity to positive infinity. The range could change based on the polynomial function, but for this one, it is going down forever and it's going up forever. So our range is from negative infinity to positive infinity as well. Next, let's look at the turning points. These are your maxes and mins. You can find these on the Desmos graph. So your max is at -3.155 and 3.079. Okay, your minimum is at -0.845 and -3.079. Based on these turning points, you will identify your increasing and decreasing intervals. So the function is increasing, and let me get a highlighter here. Your function is increasing here and here. So we need to identify those intervals. So it is increasing from negative infinity all the way until that value, that x value of the maximum, so -3.155, union, and then it increases again, starting at the x value of your minimum, so -0.845, all the way to infinity. The function decreases in between those maxes and mins. Okay, so your interval of decreasing is from -3.155 to -0.845. Okay, and that's how you identify the characteristics of this polynomial. Okay, so here's an analysis that you guys will try on your own. Graph the function below, then write a written description of the graph that includes all key characteristics below. The type of the polynomial function, domain, range, end behavior, turning points, include whether it's a relative max or min, the zeros and their multiplicity, and then the effect of the multiplicity on the graph. Okay, so if you plot this function in Desmos, you will find that it will look something like this. Okay, this is what your graph should look like. Again, it's a rough sketch. So the type of polynomial, it is a cubic, because it's a degree of 3, and it has 4 terms, so we just call it a polynomial. The domain for all polynomial functions is from negative infinity to positive infinity. The range, again, this could change based on the polynomial, but with this one, it's going down to negative infinity and up to positive infinity. So your range is from negative infinity to positive infinity. Your end behavior, as x goes to negative infinity, which means to the left, where is the graph going? Well, on the left, this graph is going down towards negative infinity. As x goes to positive infinity, to the right, where is the graph going? It's going up towards positive infinity. You have a couple of turning points here. So you have a relative max at this point here. Okay, so this is at 2, 0. You have a relative min at this point here, which this one has some decimals, so 4.667 and negative 9.481. The zeros. You have a 0 at x equals 2. Now that one bounces off the graph, so it's an even multiplicity, okay? You have one at x equals 6, that one crosses, so it's an odd multiplicity. Remember that your degree has to have the same number of zeros. So our zeros have to add up to 3. So there is a bounce at x equals 2 because it is a multiplicity of 2. Okay? At x equals 6, the graph crosses. It's a multiplicity of 1. Well, 2 plus 1, that gives us our 3 zeros. And that's how you are going to analyze these graphs.